Welcome to a new test and teardown video. This time we're going to look at some really interesting instruments. This one looks like a normal kind of meter readout, and it says cosinus phi, so that is the angle between voltage and current. And this meter here is specially made for three-phase AC, of course. So that will be the voltage input, and that is the bigger ones. That will be current. So this meter will measure the relationship between AC voltage and AC current, the phase, and then read out exactly what is going on. Unfortunately, this is made for 3 times 110 volts, and I don't have a 3-phase variable, so I'm so sorry I can't test the damn thing. Maybe we'll figure out how to test this, or if there is a possibility when we look inside. The other one here is a lot different. It's also a lot heavier. It's the same physical size, and it looks like it's the same kind of lab instrument. But look at this one. This meter can rotate all the way around, so it's very much different. And it says here capacitance, inductance, or a capacitance. The load is probably either a capacitor or an inductor, right? And then I think Bezug und Abgabe, I think that means if it is the current goes inside or outside, or in or out current. So you can probably also see direction. I could be wrong because I'm not super expert in this. And again, it is also for 3 times 110, so that sucks a little bit. And that is, of course, why they were given to me. They're also super beautiful, very decorative instruments. So yeah, I might as well just keep them for, I don't know, they're better than a plant in my window, I guess. So what I think we should do is open and see how they look. How about we do that? Isn't that just wonderful? So now we're inside, and inside one of them there is this piece of paper. How fascinating. So this explains exactly how it works. It also says that this is an MSAS054A Leitungsfaktormesser für 3 Leiter. 3 Strom gleicher Beilei. So here's the 3 different voltages. And then that is the current. Aha! So we only measure current in one of them. So I should be able to. Oh, look at that. If this is my 0 or my return, I don't have anything in this one, right? Maybe I could. But here it's called RST, and that is not the case here. That is a little bit stupid, isn't it? But okay, it goes. Maybe this is the external. So here's my instrument. Right? Probably this is external. So we got some resistors here measuring voltage, and then it goes into this instrument. Voltage, and then here is the current. Right? So maybe this is also supposed to be external, because here we got small letters here and big letters here. And again, yes, we got small letters here, so that means this is external. So this is only the instrument. We don't have any sense resistors or anything like that, right? That is going to be interesting. So that is external. Well, let's look at the other one. This one is insanely heavy. Ooh, it's sealed. Isn't that something? And again, here is a little schematic. I really would like to go a little bit more inside here. So this is model here. This MSSDR 1680T. Is there a way for me to get more in here? We got the different numbers. So I should be able to remove those wires, right? I think that is super sexy with this seal. So that means, here's a little screw. So probably that one and that one down here. That will let me take out the instrument. I really would like to have a look at this. So now, both instruments, they're out. So it's definitely super easy to rotate. That is the heavy one, and this is very, very lightweight. And also the indicator here is balanced somehow. I think it's hanging in some super, super loose spring. And then it works like that, right? I definitely want to go in here and have a look. And here is again the same schematic. And but here it's called AS137. So that is also a type number for this model. And see, it is also sealed. But I don't care, we want to go in here. Oh yeah, here's the locking mechanism. So look at those two little metal things that sticks out the side. So here's how it works. This one goes in, click, and then, oh, it was the other way around, sorry about that. So this way it goes in, and then it goes click, and then you bend it this way, and then see, when I push up, like when I screw this down here, it locks itself, and then it holds the instrument. So when you lose this, all you have to do is bend it a little bit, and then pull, click, released. But you need to know this to be able to mount and dismount this one. So we are now inside the instrument, and let's have a little look on what is going on in here. It is very difficult to show stuff and have correct light and all that. What I want to show you is, here is a voltage instrument right there, and then there's another one right there. You can see the windings. Okay, so two of those, right? And they are actually angled funny enough. So one is lying flat like that, and the other one is 90 degrees to that one. So that is a little bit interesting. And then the iron core is also divided into two parts. And then let's rotate this. So the two parts of the iron core goes to those two current sense coils, and they're just connected in series to a point, to an internal point here that is not in use. And then the two wires, they just go out here on 1 and 3, exactly as shown in the schematic. 1 and 3, that is the current. And the two voltage coils they go to 3 resistors. And those are here, right? So here is the fun part. We got different resistor value on those resistors, and that is because it's coupled like this. So here's the center point of the 2 inductors. 1 resistor here, 2 voltage, and then that voltage, another resistor, and that voltage, another resistor. So imagine those 3 phases, if they line up in perfect balance of 3-phase voltage, we don't have any problem here, right? Especially not when this current is perfectly in phase with this one, or in any of the others, by the way. That really shouldn't matter if if there's a resistor load, then this current will be in phase with this one, with the voltage measured here, right? The sum of the other 2 returning, and that will give us nothing on the meter if that is the case. Other than that, if there is a wrong phase current, we will have something on the meter. That is how this thing works. And by the way, I saw another funny thing about this meter here. Here on the back, we got a signature. And we also got, I believe, that is 1969. It could be, right? It could also be 1960. I don't know. When we magnify this very much and compensate for the stretch of this stamp, yes, it is 1960. It is really that old. There is a really funny smell to this as well. And look at that, is ceramic, and then that is resistor wire. So let's look at the other instrument, just to make this video much more complicated. We got 2 stories going on in parallel. Oy, oy, oy. This one is heavy duty. And this is made completely different. It is made like a motor, but it is a 3-phase motor. See, there's a connector down there and 2 up there, and they goes to the rotor part of it. And the stator part of it goes to those 2 current windings, and they are in this one coupled in parallel, depending on the sensitivity, I guess, right? So those 2 wires goes in parallel. And oh yeah, we got a few more really cool details. Look at that. 1963. I think that is what it means, right? So that will be the voltage resistors, and this is the schematic here is a little bit the same. Again, we got the 3 windings, of course, for the motor, and then we got those voltage scaling resistors. So what I think I could probably do, I could probably take my 3-phase generator and put in voltage to the rotor part behind those resistors, and then if I apply a DC current or an in-phase AC current to the current sensors, I could either make this work as a motor or make it indicate the angle. That will be the different ways that this can work. And they knew this one could work as a motor. As you can see, it can spin all the way around and around. And there's a funny feeling about this. When you move this real slow, there's no brake. But if you push it real fast, then it's kind of breaking. And how is this working? That is really, really cool. See this aluminium disc with all those tiny little dots? And look at the big black magnet. And there's actually 2 of them. Just that is just for balance. But that is actually eddy current braking. So when you move this aluminium disc in a magnetic field, you create eddy current in the disc, and that works like a brake. So the faster you move, the more it brakes to prevent this as working as a motor. It's a really, really beautiful construction, and there's a super, super old, nasty smell to it. Yeah, I really would like to try and power this up and see if I can make it move just a little bit. That could be more fun, right? Yeah, we got some handwriting, and that is very, very normal. When I look at old stuff like this, I always find funny stamps and handwriting and stamps and all sorts of things. This is always a lot of fun to look for. What is this? Is it broken, or is it just glue that is looking? This looks like it is not supposed to be looking like this. So this one is melted down, right? Well, look at that. This can't be good. So maybe the motor is also overloaded. There's definitely a bad smell to it. Oh, poo, yeah. What do you think I have made here? So, of course, I figured this out. That is exactly what I said. You can take the 3 voltage windings and you can connect them to a 3-phase generator that is running, in normal 3-phase mode, right? As you see here on the graphic, is also showing the different phases and all that kind of stuff. And give it a very, very low frequency. And what I've done is I've added a little bit of DC current in the current sense. So now I've actually added a permanent magnet so that the rotor got something to spin by, right? So it actually works. Isn't that cute? So I was able to test, and I was able to figure out how it really works. And of course, this is also going to work with 50 hertz and all that kind of stuff, and the phase differences and all that is, of course, going to give you a position indication, because the 2 voltage windings, they are angled to the current, and all that kind of stuff is very well designed. So yeah, this one works. Let's try and see what we can do with the other one. And of course I can make the other one works as well. It's a little bit the same way this works. Here I gave it a little bit faster frequency, but other than that, this is of course how it works. I gave it DC on the current inductors here, so that means I just magnetized those, and since the 2 coils, they are perpendicular, and then I'll get this readout here, right? So that is how this super cute meter works. It is beautiful made. It is a little bit a shame to put this inside a black non-transparent case like this. It should be seen how this is made, right? But anyway, I think that was what I wanted to show you guys today about those really old and fancy meters here. At least I had a little bit of fun. I hope you did too. See you tomorrow. Bye bye.